So Wednesdays I bike into work and shower there, and so you'll have to forgive my state of unmake.
That's why I just have the picture of the trees up all the time, because then you never know.
Okay, we are live.
It's a
and have been for quite some time.
Okay, start here we go.
Everyone's got their normal probability applet open?
Yes.
Okay.
Hang on a second. Let me pull it up.
Like before you even start, to save yourself the time.
All right, I got it.
Awesome. You guys ready? I'll start with question 3, if that's cool.
Cool. Yeah, go ahead.
All right. The total area under a normal distribution curve must equal 1.
Yep.
Yep.
Yes, that is correct.
I'll take 2 because it's going to get harder as we go. Under certain circumstances, a normal distribution curve can drop below the x-axis. I believe this is false. It has to be on or above the x-axis.
If it is false,
That's correct.
Yeah.
All right, I'll take 5. A normal distribution curve is symmetric. That is true.
Yep.
Sorry. I love some of their drawings. They're so good. Okay.
I know. It's like a 4-year-old did it.
I know. Or a doctor with a mouse. Okay.
You want to take this one, Matt?
Yep. Which of the following elements of the figure represent the z-score? The z-score would be A. Is that correct?
No.
C.
I think it's yeah, it's C. It should be the red lines.
Oh, but it's actually
Yeah.
C. Right, the numbers in the boxes.
Yeah, the numbers in the boxes are your z-scores.
Yeah, it was kind of misleading.
Yeah, I would.
Oh no, yeah. Sorry.
You're
C,
okay.
you're right.
I can see how you would have thought A too, because yeah, it should really be. Yeah, that was confusing.
Yeah. All right, Sarah, you're up.
Okay. Where am I? Which of the following elements of the figure represents probability that z will be greater than 1? That would be B.
Yes.
Mm-hmm. Yep. Okay, according to the 68, 95, 99.7 rule, what percentage of the data from a bell-shaped distribution will be within 1 standard deviation of the mean? Write your answer as a percent.
I think we skipped the question.
Oh, did we?
Mind just kidding.
No?
No.
Okay.
I just clicked the wrong.
I'm going to go ahead and write out my bell curve graph. So, am I? What percent of those is 1 standard deviation? Let me see. Oh, so that would be. Okay, help me out. I'm having a hard time getting.
This is the
68%.
This is a 68, 95, 99.9% rule, which Becky, what that's nice is 60% of the data is going to fall within 1 deviation of the mean.
68.
95.
So simple, yeah.
Yeah, within 2 and okay. Yep,
yeah. So simple. So yeah, 68. Sorry, I was going harder than that.
Well, sometimes it's really easy to overcomplicate things.
Yeah.
Yeah, I do that all the time.
All right. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. Yada, yada, yada. What proportion of the z-scores will be between 1 and -1?
68%.
Yeah, I got 0.6827.
That's once again falling under the 68, 95, and 99.
Is 0.6827 correct?
0.683.
Oh, right. We're only doing 3 decimal points.
Yep, I got you.
So I'm sorry, I've completely missed that. Where are we getting that?
Oh, so in the reading under, hang on a second. Let me find the section for you.
Okay. So question 9. If you go to the probability applet and put a -1 into the z-scores, the top number will give you a probability, which this is just backing up the 68, 95, and 99.7% rule.
Yes. So there's a link. There's a link in the body of the question of question 9.
Right. Yep. Yeah, I've got the app here pulled up, and so you hit on the app here. You hit on the z-scores -1 and 1, right?
And then you make sure that only the area between the 2 is shaded. And then the answer is in the box above where it says area.
Thank you very much. I appreciate it. I see what we're doing. Thanks,
Oh,
everyone.
you're good.
The keywords less or more between, which is silly, but you have to click that first too sometimes, or else it's a little weird.
All right, I got 10 here. Let's see if I do this right. -2 and 2 between there. All right, so number 10, I got 0.955.
Yep.
Yep.
Aces, grand aces.
Hello?
Hello? Everyone there?
Here we are.
You here?
Yeah.
Sarah?
Yeah? Can you hear me?
Yeah, I can
Hello?
hear you. Can you hear me?
Yeah, I
Yeah.
can hear you.
Also.
You have number 11?
Oh, me?
Yeah.
Oh, sorry. Sorry, guys. Okay. Number 11, I've got
Oh, you're good.
0.997.
Yes.
What I've got. Yep.
Okay, look carefully at your answers to the last 3 questions. What do you observe? Okay, so start with point.
Sarah pointed this one out a good number of times.
Sorry, what?
Sarah pointed this out a couple times as we're answering these.
Oh, okay. Yeah. Their values match the empirical rule. The
Yes.
z-score
The
increase.
value.
Yeah. A.
Yes.
Yep.
Yep.
So that is that true though? As the z-score increases, the area between -z and z increases.
No. It's that we're matching, the values match with 68, 95, and 99.7% rule.
So that must be false then. That the z-scores increase.
No, that one's opposite. Like look, if you look at this one here with the z-scores at 3, the entire thing is blue. So as the z-score increases, so does the area of probability.
Okay.
Yeah, so If you look at all your answers, we have 68%, 95%, and 99.7%, which is matching the rule.
Yeah.
Yeah. Okay.
All right. Let's see here. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that protein requirements will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.65 grams per kilogram, whatever all those numbers mean. And the population standard deviation is 0.07 grams. What proportion of the population have protein requirements that is less than 0.6 grams?
This is where we need to find the z-score. Does everyone
Okay.
remember the formula for the z-score?
Hang on a second. I've got the book open.
Do we have that memorized?
I would recommend memorizing it. I'm just going to point that out.
All right, so that's x or z equals. Hang on a second. Let me get my pen out. Oh my gosh, all these pens around here, none of them have ink. Okay.
Story of my life.
Okay. So let's see here. Z equals. What's that? That's see, what is x again? X is the
X is the data or the observation that you're taking into account. So in this case, the data would
Variable.
be 0.0. Yep, the variable.
What's that? 0.6?
Yep, 0.60.
All right, 0.6 minus the mean, 0.65. Are you serious? Okay. I'm down to scripture markers, guys.
They'll bring you luck.
Get the water paints out.
Yeah.
Find the crowns.
Let's see. Then over the standard deviation of 0.07. So that's negative 0.05 over 0.07. Should I pull my calculator out? Yeah, 0.05 over 0.07. I got negative 0.714.
Yep.
Yep. And you're going to want to plug that into the probability applet as your z-score. And then what we're looking for is the area number to the left of your z-score.
All right, stand by. So the area on the left is 0.238. 0.238.
Yep.
Mm-hmm.
So, is it, see where there's proportion, right? That lets us know that we have to plug it into the applet.
Yeah, yes.
Is that correct?
Yep.
Okay.
Just assume unless it specifically asks for a z-score, that it's that you're plugging into the applet. Okay, is it my turn again?
Yeah.
I think it's Matt. I think Matt's up now.
Oh, Matt. Sorry.
I can go on this one. So luckily we've already done the first part of the equation, so we're just going over to the app and doing more than that. Is that right? Let's see.
Yeah, go over the app and then everything to the right.
To the right of that. Yep. So it's actually well, it's symmetrical, so it's the same. 0.238.
No. So it's everything
You have to take
right of negative 0.714.
Yeah,
Okay.
because the z-score that we got was negative, so it's the left one.
Okay.
What?
Gotcha. So now we're starting. I see. Okay. So both the far right and the center is going to be 0.762.
Yep. And
Wait,
another way.
go through that. Sorry.
Another way you can do that too is because we already know that the probability of it being less than is 0.238.
Oh, right. You can just subtract it from one.
You can just subtract from either one works. Like either
Makes
way
sense.
is fine.
So 1 minus 0.238. Okay. So 0.762?
Yes.
Okay.
If I sound like an annoying know-it-all, call me out on it. I'm just trying to be helpful.
So
No. We would be lost without you.
No. I'm sure you'd all be doing fine, but I mean, by all means, let's be awesome together. Okay.
I just can't go quite as fast as you can, Sarah.
No, it's I have an unfair advantage. I'm willing to admit I have an unfair advantage. You see, so actually, it's my second time taking class. I actually was doing really well in the class until I got sick, and so I'm like, oh yes, I remember this. So.
Yeah.
That's awesome.
But if I come across as a condescending jerk, you tell me.
We'll let you know.
Okay, thank you. We had somebody in the class I was with last time, and he was a similar situation where I am now, and he came across as a little bit of a jerk. So I'm like, I don't want to deal with you.
So you feel like you've come full circle.
I appreciate your help.
Yeah. So. Okay, so what proportion of points? Okay, so if we look at this, it's going to be the positive of what we got last time.
Yep.
Question.
Are we looking at question 14 or 15?
15. We assume 14
Okay.
was 0.762.
Yeah.
Because it's the positive 0.5 over the is that right? I can't even think right now.
Yeah.
Oh, yeah, you're
0.05.
right.
Yeah, 0.05 over the 0.07. So it's
So we can just do the right side of the positive z-score then, correct?
Yep.
Which is the same.
Hold on, you guys.
It's the left side. It's the left side of the positive z-score, which is the same answer that we just had before.
Oh yeah, sorry, you're correct.
No, you're okay. That's why we
Give me just a second.
always. You always want to double check your answers. Oh, sorry, Becky.
I'm so lost. You gotta go a lot slower than that one for me.
What's that? What's that, Becky?
Can you go over that again, Sarah? Yeah.
Okay. Yeah. Hang on. So you get we wound up getting negative 0.05 over negative or over positive 0.07.
Yeah.
We subtracted -6 from -6.5. This time we're subtracting 0.7 from 0.65, meaning that we're going to wind up with positive 0.05 over 0.07, which is the exact same number except positive from the last z-score.
Okay. Gotcha. Okay.
And then we just need to figure out what's less than. So we just need to do we just need the center and the far left highlighted, which is going to give us the exact same answer as what our answer was the last time.
0.762. Yeah.
Yeah, so we're just trying to figure out what's left of the positive z-score from the last problem.
Gotcha. Okay. My turn. Find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70. And remember that to find the error between two values shades the left of each z-score you calculate and then subtract the smaller area from the larger area. Make sure your answer is covered. So our answer for the 0.6 was
That was
what?
left up was 2.2376.
Yeah, and then our 0.7 was
Or 0.7624.
0.762. So we subtract 0.238 from 0.762.
624. When you do these, always make sure that you write out your decimals to at least about 4 or 5 places. Because if you round up for your answers, that's great. But then when you go back down to work the problem, they want you to have the full decimals, if that makes sense.
Okay, so the answer on 15 should be 0.764 though, right?
0.7624.
Okay, I'm mistaken. But it says
Wait, which one was that for?
So it should be 0.762 on 15.
Okay.
Yeah.
So for this one here, since we're trying to figure out what the protein requirements are between 0.6, which we know is our negative z-score, and 0.7, which we know is our positive z-score, couldn't we just plug it into the applet and do the area between the two?
No, it doesn't work that way because your applet, you can't put two, like your z-scores always mirror each other. Does that make sense? It's always the positive and the negative of the same number.
Well, yeah, sure,
In
yes,
this
I
case,
do
it works.
know that.
Not all cases, but I think this case it does work.
Yeah.
Oh,
Because the 0.6 we did the math on 0.6 wound us up with negative 0.714 as a z-score, and 0.7 wound us up with positive 0.714 as a z-score, which happens to work with our applet.
yeah, no, that happens to work this round, but I wouldn't necessarily ever bank on that happening.
Okay, all right, that's fine. But okay, so we need to. Let's see here. Where's the equation for this?
The
equation.
Subtracting 0.238 from 0.762.
4. Always go to 4 digits.
7.624.
Yeah. Otherwise, it'll
8 what? 0.238. That's my fourth digit. 2376.
Yep.
Uh-huh.
0.2376.
Okay, so 0.7624 minus 0.2376 gives us 0.5248. There's a good. Did you guys watch the videos at the last videos? The where it's the young guy and you can see him on the chalkboard. Sorry, I don't know where they're at. And he gives an example of this and writes out the reason why you can't depend on the applet all the time.
Well, I do understand that you can't rely on the applet all the time.
Okay.
Yeah.
Okay.
Yeah.
We're better off with.
Sorry, go ahead.
Okay, so our answer is 0.5248 here on 16.
Yes, 0.525 for each of those places. Yeah.
Okay.
Yeah.
0.525 for 16.
Now let's see here. This one here, I don't quite remember how to do this. Number 17.
Do you guys want me to walk you through it?
Yes, please.
Okay. So go to your probability applet.
Uh-huh.
In the area, put in.
Oh, that's right.
Put 0.35 in.
Okay.
And then what you're going to do is you're going to write out the z-score, formula that you're going to use that z-score of negative 3.85 because you're looking for the 35 percentile, which would be the lower red line. Not to be confused with the upper line, your 65th percentile, which has led to one or two silly mistakes on my part in this class before. So 35 percentile is your first line. And so you work your equation using that.
So it's negative 0.45 equals
Negative 0.45. I've got negative 0.385.
negative 0.385. Oh, hang on a second. I haven't hit return yet.
Okay, so your area should be 0.35.
Yeah.
When I go onto that applet, I type in 0.35 and it comes up with an error. Am I doing something wrong there?
I think that's where you have to, if you,
I mean, you just type in the area box 0.35, right?
yeah, you have to click
So
around down in the class.
You want to make sure that something's highlighted. Then it can like click around. If nothing's highlighted, then you're kind of messed up.
Yeah.
Every time I do it, it just takes the area back to 0. Nothing's highlighted, 0.35, and takes it to 0.
Okay, so Matt, highlight to the left
Yes.
the red line.
Yeah.
And then type your area at 0.35. Does that work?
It still takes it back to 0.
Try exiting out of the applet and then basically just reboot it. So reopen it.
Okay.
That makes sense.
Yeah. Okay, so I don't have anything highlighted. I type in 0.35.
No, you have to highlight first. You want to highlight the left first.
Yeah, highlight to the left first will simplify life.
Oh, I see what I did wrong here.
Okay.
Okay, you got it?
0.385, right?
That.
Yep,
When
negative-
you highlight
negative.
the areas, it's touchy.
Yeah. Make sure you set up the
Thanks.
negative. No worries.
Thanks for your help.
Oh, that's why we have. This is why I think this is the big reason why we have the group activities. Is because it really does. You catch stuff, you're like, wait a minute, I didn't quite get that. And somebody else can explain it.
All right, so I got the z-score is negative 0.38. Multiply that by 0.07 and get negative what's that?
Let's back up for a second because I want to make sure that everyone's got this. Has everyone got the equation written out correctly?
So the equation that we have. What's that?
Are we still on 17?
Yes.
We're on 15.
Okay.
Oh, 18.
Or 17.
So that just gives me score.
Oh.
So then the equation written out is x equals mu plus z times
I would.
Wait, hang on a second. What was number 17?
So we haven't done 17 yet.
we're still
We're done 17. So
all right. Okay, so the equation should be z-score equals x. In this case, that's the protein requirements that we're trying to find. Minus u, which is the mean, over sigma, which is the standard deviation.
yes. And so it's
we know that the mean is 0.65. And the sigma, the standard deviation, is 0.07.
Yes.
So now we have z-score equals x minus 0.65 over 0.07.
And if we go to the normal probability app, and we type in that 35% for at the area, the 0.35, that gives you your z-score of negative 0.385.
Yes.
So we know that the entire equation is going to equal negative 0.385. Then you want to times both sides by the by the 0.07. And then you'll add that answer. Then you'll add the 0.65 to that.
So I got negative 0.02. We'll call it 0.7. So negative 0.027 for equals x minus 0.65.
So you want to add the 0.65.
What's that?
Then you want to add the 0.65 to both sides.
Yeah. Yes. Correct. Plus 0.65. So the answer is x equals 0.623.
Yep. So one thing I will tell you. Is that when you're doing all your math on these, make sure you are not rounding it. Like you put it at the answer in, but make sure you do not round it until the very, very end.
So Sarah,
I think we lost you there for a second.
What, Becky?
Is this a situation where we could use the equation x equals mu plus sigma, or plus the z-score times sigma, like just rearranging that equation, right?
Yeah, you can. The only thing I ran into that, because that's from previous experience with some of these equations, I thought I was being clever and I did that, and I made a mistake when I did it. Does that make sense? In rewriting the equation. And so I got it wrong. I have found that a lot of times it's just easier to put the numbers into the original equation and then rework the numbers that way.
Okay.
Just because
but it works.
Yeah, that would work just fine. For me, because I often will miss like small details. Not that I'd be guilty of that. It just makes it so I make sure I work all the way through. I don't miss something.
Yeah, gotcha. I think I'm the opposite.
Yeah, no.
I don't remember my algebra rules well enough, so I like to just memorize the formula.
Yeah, no, you're good.
All right, I'll do number 18 here. Is everyone ready for 18?
Yeah.
Okay, this way I can make sure I'm doing it right. I'm pretty sure I've got it. So go to the applet and you highlight the left area, and you put in your average of 0.8. Your area of 0.8, excuse me, which comes out with a z-score of negative 0.842. Does everyone else get that?
You want the positive on the side.
Yeah, positive 0.842.
Oh.
So, Mark, do you remember the box score or the box plot from last lesson?
Yeah.
Okay, so if you look at the normal probability applet, think of the far 4 and the far 4 on both sides, negative 4 and the 4 as your whiskers, and then think of your the big red lines as kind of your quartiles, not exactly. And so if you look at it that way, the first, like the far quartile is going to be the large percentile. Does that make sense? Yeah. Yeah, so you want the 80 percentile, which is going to be a far one, which means 20% to the right is going to be what's undone. It's going to be unhighlighted. Like.
Gotcha.
Does that help?
Yeah, that helps.
Right, highlight.
I've highlighted the far right to the right of the right line. And then for the area, you type in 0.8, which comes up with a positive 0.842, right?
Yeah, right, positive 0.842.
And you set up your equation. I'm just getting the math done here. So I've got our answer to be 0.709.
Yep. 0.09?
709.
What was 17? Was I right on that one? Was 17.623?
Can we go back from 18 and just call out the answers? Because I think I got off somewhere.
Yeah, 17.623. All right, so go back to, do you want to start at question 1 and just make sure that we're all on the same page? I mean, question 3, technically.
Yeah.
So question 3, I have number 1. I have 1. Sorry.
One second, I'm not there yet.
Okay, perfect.
Okay, yeah, so 1.
1. Then false. Then true. Then C. Then B, as in boy. Question 8, I have 68. Question 9, I have 0.683. Question 10, I have 0.955. Question 11, 0.997. Question 12, the values match the 68.95 and 99.7% rule. Question 13 is 0.238. Question 14 is 0.762. Question 15 is 0.762. 0.525.
Your message.
17 is 0.623. 18 is 0.709.
Cool.
All right.
All right, everyone needs to
Sarah,
submit.
thanks for your patience with us as we're all learning it. We appreciate it.
Hey, no worries. You guys are fine. And some of the stuff I'm still like, oh, there's some stuff that didn't make sense to me last time that's like magically clicking. I think it might be the fact I'm not in my third trimester anymore. Okay,
Probably someone did that.
That's a good feeling.
I know it's nice to have my brain back mostly. Okay, everyone hit the submit quiz together. 1, 2, 3. Sorry, I'm gonna be less snarky about that. Okay.
That was a little tough. We got 100%.
Yeah, we got 100.
Well done.
Nice
Yeah.
job.
So what did we want to talk about with the final project?
Okay. So if everyone takes a second. Oh, that's my thing. Okay. If everyone takes a second and go, if you click on the content tab for lesson 5, or not lesson 5, content tab in the Math 221A. If you scroll all the way down past week 14, you have a final project. At the very, very top, sorry. Everyone there?
Yep.
Okay. You have the final
Yep.
project overview. We can play with that later. But then you have design the study instructions, which is, so this is due November 11th. And I kind of think this is a dirty trick, to be honest, because they set it up so it's like the last 4 weeks of class, you're trying to do this big study.
So you're just like sprinting?
Yeah, you're sprinting. And so I look at it, I'm like, there's nothing in the rules saying, unless we get told for some reason that it's inappropriate, there's nothing in the rules saying that we can't start looking at it now and start working at it now. And right now, I feel like we all understand the concept of a study design well enough that we could start working on this. So we can get it done way before that event. We have to get so we have to get our study idea approved by Brother Bennett.
Okay.
And so if you click the design the study assignment that's in that folder, it starts giving you kind of what you're into. I will toss this out to you guys. If we do an observational study, there's no additional paperwork. If we try to design an experiment, we have to go through IRB, which is basically people making sure you're not doing inhumane things and unethical things to other people through the university, which is a pain in the neck.
That sounds terrible.
It is terrible. Unless you're a master's student, you don't want to do it. An observational study. Now, I also have the advantage that I can kind of talk with my parents about it. And so an observational study, what we can do is we can decide something we want to study and design questions. And we can what my dad has seen other people do in their classes, which has been really successful, is that you put the study on Facebook and you let people fill it on Facebook, but you put demographic questions at the end, and then you can sort out the demographic that you want to be testing. Does that make sense?
Yeah.
Yeah.
And so, and when I was talking with him about it, he said that they have. He's like, he did this when he did his doctoral stats class. That's what they ended up doing. And he's like, we got a ton of responses, more than we'd ever want, and then we could just sort it by which demographic we wanted to be testing.
Okay.
Which is nice. And then Facebook, everyone likes Facebook, and everyone likes to take a quiz because it's very important. So we can, do that. The document, if you look at it, open.
Looking at the design the study document.
Yeah, design the study document, which for some reason is taking forever to open on my computer. Come on, little document. We can be friends. Okay, design the study instructions. Lovely. Oh my gosh. Yeah. I feel like we're going in circles. Okay, fine. Okay, here we go. Now it's okay. So if you look at this, we put all of our names on there. It looks lovely. We did kind of divvy up what we're doing. At the very bottom of the first page, it says you are to create your own research question based off the interest of the group. Here's a list of examples of previous studies. And by the way, we are not allowed to use any of these or anything that's too similar to these. This list is not an exhaustive list. Please be creative when you form a research question. So if you look, are there 1,000 chips in every bag of Chips Ahoy? Is brand A toilet paper better than brand B? Is there a difference in price at the bookstore compared to available online? Are men or women more likely to walk across the grass if they're walking behind someone who walks on the grass? So it's really basic. We don't need to be too in-depth with our research. We could do something but there's two things he runs into. One, he wants the question to be original. The other thing that he really was stressing last time is he wants it something that we can apply to our lives. So for that final step of take action, we really need people to actually take action off of it. So it can't be something ridiculous, which I think would be funny. But so an example of something I thought about is, so I do dog training. One example we could do is who's more likely to be bitten by a dog, men or women. And we really could just set up a survey monkey with the, have you been bitten by a dog? Are you a man? Are you a woman? And I think something like that would be very doable. Our takeaway from that is,
how do we change that though? What action would we take on that? Because I can't change that I'm a woman.
Well, you can't, and the argument, and that's where you start running stuff like that. With that, we could run into the fact that if you know that you're a man and you're higher risk of being bit, then you avoid dogs more. Another thing we could do is, I'm using this example because I've been kind of toying with it, but not because we have to use it. But we could do a study based on common behaviors that lead to dog bites in youth, and we could in like high school age children, we could get a couple of these studies out to a couple different high schools, like in one of our states. We just ask them if they're willing to participate. Usually principals will say, yeah, sure, especially if we keep it short. And so we could ask if they've been bitten by a dog, and if they've ever barked back at a dog, if they've ever ran from a dog, if they've ever hit a dog, and things like, does that make sense?
Yeah.
Yeah.
Things to avoid doing around the dog.
Why don't we start an email thread, and we'll think about it, and we'll bounce the ideas off each other over the course of the week, and then next week we'll settle on something.
I like that plan. Let's toy with it. And then when we come up with something, we'll run it by the professor and make sure that he's okay with that, and then we'll start working on it. Because I'd rather
Okay.
work on this now, while our workloads are low, rather than the end of the semester when we're all trying to do final projects and finals.
Yeah, that makes sense. So why don't you guys just reply all to the email that I sent out with this week's link, and then we could just go from there.
Good idea.
Okay.
Cool.
All right.
All right, guys, I'm gonna stop broadcasting now.
All right. You're awesome. Thanks, Mark.